Hello, I'm Dirk Van Vliet. It's Monday, the 1st of November, 2021 in Otley, and I'd like to tell you about a couple of anniversaries on this particular day, and then go on to talk a little bit about some recent advances in Saturn. So, anniversaries. On the 1st of November, 1971, this was the first day that I worked for the Transport Division of the Greater London Council, GLC, and when I came in on that day, they told me they were working on a 4-stage traffic model. 3 of the stages had already been allocated, so I was going to do traffic assignment. Fine, I said, what's traffic assignment? They told me. I said, okay, I'll do that. And 50 years later, I'm still working on exactly the same problem. The second anniversary is on 1st of November, also a Monday, 1976, when I was then employed by the Institute for Transport Studies, University of Leeds. We started work on the Saturn project on that day, and John Bolland came and started as a research assistant. So 45 years later, we're still going strong on Saturn. So next, I would like to describe some of the recent things that I've been doing in Saturn during the lockdown period. One of the advantages of the lockdown period is that most of the day-to-day concerns disappeared with Saturn, and I was left with more time to look at the fundamentals. So these are 5 fundamentals that I've been looking at, and I'll try and do this using a PowerPoint presentation. So if you wait for a minute, I will share a screen. And open up PowerPoint and go into a slideshow from the beginning. So there have been 5 improvements that I would like to talk about. 2 of them, Celeste and Lucien, are to do with tree building. The third one is a different method of doing Frank Wolf assignment called simplicial decomposition, which has been around since the 70s. Finally, 2 methods for storing trees in a slightly different format and to eliminate certain links while you're building trees in that format. And collectively, they may lead, hopefully, to several orders of magnitude reductions in CPU when you come to do things like select link analysis or post-assignment analyses. So looking at these 5 things in somewhat greater detail, the tree building algorithm Celeste is basically a Dijkstra type algorithm, but it has also certain touches of DeSopo associated with it. So where it differs from Dijkstra is that it does not have a completely correctly sorted list of candidate nodes, but it roughly sorts them into bands, which means that you may make certain mistakes, but the time spent sorting the loose end table is much faster than Dijkstra. And if you have very, very large networks, e.g. the Lohem type networks, the CPU time may be reduced by something like 50%. The second tree building algorithm, or more correctly, a tree correction algorithm, is an example of when you have to build trees when the link costs differ marginally from one tree build to the next. For example, this occurs during post-assignment analyses when you're working through different iterations of the Frank Wolf algorithm and the costs are changing only by small amounts. So what Lucien does is it simply processes the nodes in the tree building in exactly the same order as the previous loose end table. This may make some errors, but if you make errors, you correct them immediately using DeSopo rules. So the advantage of Lucien is that it gives you a very, very simple loose end table structure. There's no need for sorting. It's very fast, and potential CPU reductions are factors of greater than 2, one would hope. Thirdly, using simplicial decomposition, you can do what's called the Sabit assignment in Saturn, whereby you follow the normal Frank Wolf process, but each time you add a new iteration, you loop back over all the previous iterations and reassess their optimal weights, which means hopefully that some previous iterations will now have a weight of 0, which means you can remove them from the solution. And this leads firstly to significantly improved gap values and much fewer positive iterations remaining. So you may be able to work with, say, 50 iterations rather than 256, which means therefore when you come to do your analysis, such as SLA, based on rebuilding trees, you only have 50 trees rather than 256 to consider. So everything is speeded up by a factor of 5. UFF files are a method of storing trees using an incremental method, so that rather than storing the complete set of trees over all iterations, user classes, and origin, you only save the changes from one tree to the next, which means on an average, you need 10% of the RAM required to store the full trees, which means, again, analysis becomes much faster since you don't have to build the trees each time you're doing an analysis. You just input them from the UFF file. A further advantage of building UFF files is that you can eliminate the backward links while you're doing so. Basically, this means that if you're building successive trees from the same origin, you build the first one, and then you can identify which links are going effectively in the wrong direction. For example, if you're building an origin tree based in London and you have a destination zone in Leeds, then clearly the northbound links on the M1 are going to be highly important. But the southbound links on the M1 will never be part of the trees because they're part of the routes from London to Leeds. So by eliminating southbound links on the M1, for example, you can reduce over 50% of the available links, and therefore you reduce the 50% reduction in CPU time. So together, these 5 methods, as I say, will hopefully give you a reduction of 10 times, 20 times, maybe even 100 times in things like select link analysis. So I will stop my screen sharing and say, if you have been, thank you very much for listening. Bye-bye.